Before we start building the Java class for our model for the BMI calculator app, I would like to give you a short introduction to one of the main ideas we would like you to understand for this course, namely object orientation. So Java is a programming language and it specifically follows a programming paradigm called object-oriented paradigm. So I would like you to understand object orientation at least to get some intuition so that before we talk about it formally in the lectures, you can at least get a feel about how it works and then you can start developing your object-oriented code in Java. Let's just go through some slides to get some idea. It's completely informal, but I would like you to understand how what's really the essence about object orientation. At the end of this video, you really have to understand what classes are, objects are, attributes, and methods. So these are the things that will be crucial for you to develop your code. Okay, object orientation. So I would like you first of all to understand why we need object orientation. So basically, it's more like a three-phased process for us to really simulate what's really happening in the real world. So I would like you to show you this diagram over here. So this diagram here basically shows three steps over here. So I would like you to go through with you step by step. The first step is we observe how the real world entity behave. Okay, so let's go to the diagram over there and then to see. Okay, the first step over there is called observe. Okay, so observe over here. Okay, so that's the first step over here. Basically, this is observe. So in the real world, we say everything is an entity. For example, a desk, a pencil, a computer monitor, or a trackpad, or a classroom, or a course, or a student, or a professor. So everything that you can name in the real world is an entity. Okay, so entity here is really a word that you should really know, entity. So there are so many entities over there, you don't necessarily would say one entity is of the same nature of the other entity. For example, you wouldn't say a course entity is similar to a classroom entity. They're actually quite different, right? Also, you wouldn't say a desk entity would be similar to a chair entity. Okay, so that means we have to somehow classify entities. Okay, that's really important. Okay, so somehow we have to classify entity. Classify entity based on our observation. So let's say based on our observation in this particular example, we have two classes of entities. So each class means a kind of entities. So over here, the first kind is we have a person called Jim, another person called Jonathan. So these two entities are actually quite similar in their nature. For example, let's say when we talk about person, let's say this is the person for Jim, and this is a person entity for Jonathan. So think about what they might share in common. Let's say, so both of them have an attributes. Attribute is really about a characteristic that we can use to describe a particular entity. For each person, like a Jim and Jonathan, they have an attribute called age. And then they also have an attribute called weights. Also, they can have an attribute called heights. About how many attributes you really want to use to describe a particular class of entities is completely up to you. For example, let's say for our BMI calculator, we simply use two attributes. We actually use three attributes to describe what a person is. We use the name, we use the weight, and we use the height. Okay, so now we can see that every person entity has an age, has a weight, has a height. So attributes are really common for a class of entities. They're really common. Okay, they're really common. Okay, common here is really important. I will just introduce a contrast in just a moment. Okay, they're really common. So now think about for Jim and Jonathan. If in real life, if you talk about Jim and Jonathan, they're two different persons, even though they're both persons, they're the same kind, which means they got age, they got height, they got weights. But do their attribute values necessarily be the same? Okay, that's the question. So for example, do you think Jim's age will be necessarily the same as Jonathan's age? Not necessarily, right? Because for each person, even though they got age, height, and weight, but their specific values for the attributes might be different. Okay. So for example, let's say the following. Let's say for Jim over here, his age might be maybe 45. And for Jonathan over here, his age might be 55. Even though they have age in common, but the attribute value, one is 45, the other one is 55. So what's really common for each class of entities are their attribute names, like age, weight, and height. But what can be different are the values for the attributes for the specific entities that we talk about. Okay? And then, so here, I'm going to write it down here. So attribute values, they are different. Usually different. Well, they might happen to be the same, but in general, they can be just different. Different between entities of the same kind. Okay? Now they can be different, but that's attribute value that we talk about. Attribute values, and then they can be different. Okay, we will see more example for illustration, but this is really just about observation. So that's the number one thing. So again, because there are so many entities. So let me just recap this phase. Okay, let me start from scratch. Basically, we talk about entities in the real world. So there are so many entities in the real world. For example, we might have Jim, we have Jonathan, and we have two-dimensional points. For example, let's say for the two-dimensional points, so let's say you have the two-dimensional plane over here. So you may have a point which is 2 and 3. Let's say this is P1. And also we have another point which is -1, -2. Let me just put another one, P2 over here. Let's say it's 4 and 1. Okay, P1 and P2. Okay, so you can see P1, P2, Jim, and Jonathan. So these are all entities, but they are not necessarily the same kind. Jim and Jonathan belong to the same kind of entities, like persons. And P1 and P2 belong to just another class of entities, like two-dimensional points. Okay, now for every class of entities, you can try to describe each entity using attribute names. So attribute over here. Attribute over here, and the attribute names are actually common for all the entities. For example, Jim and Jonathan, because they are both persons, so both of them have age, weight, and heights. So age, weights, and heights. On the other hand, for each entity, they might have some entity-specific values for the attributes. For example, Jim's age may be 45, and Jonathan's age might be different, which can be 55. And Jim's weight may be different from Jonathan's weight, and Jim's height can be the same as Jonathan's height, but it may be different. Okay, so that's really the first stage. Observation is really important. Okay, so that's only about observation, nothing about programming just yet. So once we have observed what's really in the real world, we're going to do it in the second phase, which is called model. Okay, let me just go back to the slides and go over that. Once we observe, we model. We model the common attributes, as I said before, the common attributes and behavior of a set of entities in a single class. So what's really the behavior? The behavior means, given that we got attributes for each entity, those attribute values might change according to some specific behavior. For example, let's say for the person. Okay, again, let's talk about the person example over here. What can be the behavior? We have Jim, we have Jonathan. So these are the two entities in the person kind, in the person class. Okay, so now let's say there is a behavior called get older. For example, I'll put a different color here, get older. Get older. So this is a behavior. So what does it really mean to get older? Get older means we're going to somehow change the values for the attributes of the entities that we are talking about. For example, if I say Jim get older, that means he will go from 45 up to 46. If I say Jonathan get older, now he will get older by going from 55 into 56 in terms of age. Okay, that's a behavior. So both Jim and Jonathan, they can get old. That's the same behavior by adding 1 to their age. However, the consequence of getting old might be different depending on which entity you're talking about. Okay, let me write it down for you. So now, let's just also get used to the dot notation. So now, how do I know Jim's age? So I can say Jim dot age. So the dot notation here, you can think of the dot as a way for us to get information from entity. So over here, Jim is the entity. I'll just write a few more and then I will try to introduce the term. And also you can say Jonathan dot age. And then we say Jim dot get old. And also Jonathan dot get old. Okay, continue into here. And then we say again, what's Jim's age? Jim dot age. And then Jonathan dot age. Okay, over here, let's highlight the relevant part. We got Jim, we have Jonathan, Jim, Jonathan, Jim, and Jonathan. So before the dot, we just give some the so-called context entity. Okay, so the yellow part over here is called the context entity. So context is really the key here, context entity. That means I want to know the age of some person entity, but who is the person entity I would like to know the age about? In this case, Jim, in this case. And I also want to know the age for Jonathan. So that's why I put a dot notation here. Okay, so this is the context over here. This is the information I would like to retrieve. Okay, Jim.age and Jonathan.age. You can see the age over here are the same because we say that every entity of the same kind share the same attribute. However, the values might be different. In this case, Jim.age will be just 45. And Jonathan.age will just be 55, as we said before, 55 and 45. Now, let's say they get older. So all the person entities can get older, including Jim and Jonathan. When we say Jim.get older and Jonathan.get older, the way they get older will be the same, just adding 1 to their age. However, the consequence of getting older for each individual entity of a person kind might be different. For example, after Jim.get older, what would be Jim.age? In this case, that should be 46 because we talk about Jim specifically. We'll go from 45 to 46. And then the next one, we also try to see the age for Jonathan. Now, this time the context is Jonathan. So in that case, that would be 56 because Jonathan's age used to be 55 and now after getting old, which would be to increment his age by 1, so that will go from 55 to 56. Okay, that's kind of the behavior. Again, you should really understand attributes and behavior. Okay, and we still have the term attributes when we talk about Java programming, but when we talk about behavior in the context of Java programming, we talk about methods. Okay, you can think of behavior is more like a general term. However, in Java, we talk about methods. Okay, the way we define how the behavior should exhibit is by defining methods, which will be just a block of code to see how you can increment the age, for example, or increment the weight, or increment the heights. Okay, so that's the second phase. Okay, the third one is really why object orientation really shines. Okay, so now let's say you define Java classes, which we'll talk about how you can do it in the second one. Okay, we talk about different attributes and also define different methods. And now what does it really mean when we try to execute a program? When we say execute, that means we're going to pass our program in the Android Studio editor, and then we pass the program for the Android Studio execution or the computer just to execute our program. In that case, we say that as soon as the computer, so this one term I would like you to, two terms I would like you to understand very well. One is called compile time. And then the other one is called runtime. Okay, so what's the difference between these two? We'll refer to these terms very often. So runtime simply means when you are, it's actually it's really the time you spend on writing programs. on writing programs on editor. And the editor over here, for example, it can be your Android Studio, right? Okay, so we say that when you are actually developing your Java program, you are actually at a compile time, which means you haven't really run, you haven't really executed your program just yet. Okay. Okay, that's the compile time. Okay, compile time, there might be two consequences. Okay, either you have some errors or no errors. Either with errors or without any errors. In the case where you have errors, then you're in trouble, because that means the computer noticed that you got some syntax or logical errors. Oh, sorry, you got either syntax or some, we'll talk about type errors. Okay, we'll talk about all these terms later in the course. It can be either syntax or it can be type errors. Let me give you a quick example. What can be a syntax error? For example, you write a print statement over here, but you forgot about the semicolon. That can be a syntax error. What can be a type error? If you're trying to manipulate values in some inconsistent way. For example, if you say, I want to have York multiplied by 4. Okay, you can see this one doesn't make sense because you're trying to manipulate the values in some nonsensible way. How can you do multiplication between number and a string? That's not possible. So that's a typing error. Okay, so syntax error and type errors are basically the sources of error at the compile time. If your program has any compile time errors, that means you cannot execute your program. Okay. Now, in the case where there's no errors, then you can move on to the runtime to say, now I want to launch my app, or now I want to run the tester to actually see what's the effects. And at the runtime, and then we're going to just execute a program. That means execute the program by computer and see the programming effects. Okay, so again, it's really important for you to understand the difference between these two terms. One is called compile time. The other one is called runtime. Okay, compile time versus runtime. Okay, compile time is when you are in the program editor, which may or may not have errors. In the case where you don't have errors in the compile time, you can move on to the runtime by executing your app or by building your app and launching it, for example. Okay, so now let's go back to our slides, and then so now when we execute a program here, what really makes object orientation shine in the runtime is we're going to see this kind of visualization a little bit later. So when you try to define, for example, the person class, and then you declare name, weight, and height as the attributes, when you try to execute this program at the runtime, somehow this particular class over here of entities will be instantiated, which means we're going to create instances or objects for this particular class. And each class over here, you can see that these, okay, let me just go back to the diagram here. Okay, over here, I just want to draw your attention to this one here. So now, for example, you can see that over here, this is what's happening at the runtime for Jim. So basically, we have a person objects, person instance, and then we have name, weights, and height. So these are the attributes with the value Jim, 80, and 1.80, whatever value it is. And then we also got Jonathan, and also just another person objects, and then with the name, the same attributes, and different attribute values. Okay, the same attribute names, but different attribute values. So now, you can see that over here, this particular person runtime objects over here correspond to what we just observed in the first phase. Okay, so that's something I would like to draw as a conclusion. Okay, so you can see the runtime instances correspond to real life entities. Okay, you see that this particular instance or object at the runtime that we program from Java correspond to what we observe in the real life as Jim of a particular person. Also, you can see over here, this person over here, let me use a different color. You can see over here, let's say this person objects for Jonathan over here correspond to this particular Jonathan object over here, right? Okay, so they correspond to each other. Okay? So that's really the conceptual intuition I would like you to acquire from this video. Maybe you wouldn't understand this video right away, but I would advise that you keep rewatching this video as we progress with the course. Hopefully you will appreciate everything I say in this video. Okay, so now let's talk about object-oriented programming very quickly. Okay, in real life, we say we got lots of entities, and then however, not necessarily every entity is similar in their nature. For example, you wouldn't say a two-dimensional point at 2 and 3, the x-coordinate being 2 and y-coordinate being 3, is of a similar kind, is of the same kind as Jim, is a person, right? So that's why you got to classify them. Okay, so for example, you got persons, and you have cards, you got clients, you got different kinds. So every time if you want to model or you want to program a kind of entities, you use class in Java. That's why the term class in object orientation is really important. Class simply means one kind of entities. Okay, and the class can be instantiated or can be instantiated into different instances. For example, the person class can be instantiated into a Jim instance, or it can be instantiated to a Jonathan instance. You can instantiate to as many instances as you wish. And for entities, so entities, they for a particular kind of entities, they have attributes like a name, weights, and heights. And also they exhibit behavior. For example, for every person entity, they might gain weights, they might gain heights, they might get taller, they might get older. And also they might interact with each other. For example, two persons might marry each other, or one person might become the supervisor or mentor for another person, right? So they interact with each other. So now what's really our goal for this course by learning object-oriented programming? We want to solve the real-world problems, but because every time when we have any real-world problems, we can always observe entities. So once we observe the relevant entities, we can solve the problems programmatically we can classify all the entities we are interested. For example, in the case of the BMI calculator, the only kind of entity we are interested in will be persons. Okay, but maybe later on when you talk about an application for bank account, in that case you might have bank as one class of entities, you have account as a class of entities, you have also customer, and etc. And also entities in the same class, entities of the same kind, they share common attributes and behavior. Okay, so the attribute names will be the same, but the values for attributes might be different among the entities. And the behavior, the definition for the behavior would be the same. For example, how does a person grow older? Add 1 to their age. How does a person grow heavier on their weights? What add some weights to it? So the behavior, the definition for the behavior will be the same. However, the consequence of applying the behavior to some entity might be different. For example, Jim getting older might be different from Jonathan getting older. Okay, and then you can manipulate these entities. We'll see how you can manipulate entities programmatically later. Okay, so now basically this is the some description for some real-world problems. So we can say a person is a being, such as a human, that has a certain attributes and behavior constituting personhood. Okay, a person ages and grows on their heights and weights. Okay, so now based on this description here, you have to somehow to realize what's the entity we are interested in. In this case, a person. Okay, and then so what kind of attributes does a person have? So usually for class and attributes, look for the relevant nouns. And for methods or for behavior, look for verbs. In this case, you can see a person ages, so there's a verb. So that means get older. And also grows on their heights and weights. Grows on their heights and grows on their weights. So these are the behavior. And then we also have the also the attributes, which can be, that's something we'll see. Okay, so now we have a template. Basically, you can think about a class is simply a template. And for person, that's going to define all the common attributes among the entities. So the attributes over here, age, weight, and heights. Also, we can also define the common behavior. How does a person get older? How does a person get weight? The same way. However, applying the same behavior but to different context entities, you might have different consequences. Okay. For example, if you say Jim that get older versus Jonathan that get older, as we described before, right? So we said that it's going to be different over here. Okay. Remember, we say Jim that get older over here versus Jonathan that get older. It might be different because the context we talk about are different. Okay. Okay. So now, so let's talk about persons again. So person, they share some common attributes and behavior. So now each person has a weight, as in age, weight, and height. And also, however, the values will be distinct. Okay, we have emphasized that quite many times already. Okay, and then for example, you say, so Jim has an age. Okay, let's compare side by side. Jim and Jonathan. So these are two instances of the person template. Okay, so these are two entities of the same kind. So both of them have some age. In the case of Jim, it's 50. In the case of Jonathan, it's 65. And both of them have some measure for their heights. In the case of Jim, it's 1.8 meters. In the case of Jonathan, it's 1.73. So you can see both of them have the heights, but the values for the specific entities might be different. And also, one is 80 kilograms, the other one is 90 kilograms. Okay. So you can see that it's quite intuitive. It just matches to real world phenomenon. And then, so each person, depending on their specific values of their attributes, for example, let's say this. For Jim, because his age is 50 years old, when he gets older, he becomes 51. Okay. But for Jonathan, because Jonathan's age is 65, now if you say 65, get older plus 1 as well, that'll be 66. So the way these two entities get older is the same. Just add 1 to their current age. However, the current age for different entities might just be different. For example, 50 and 65. That's why I got 51 and 66. The consequence is simply different. Okay, what about BMI? Similar idea. Because we know that each person has their weights and heights. Each person does. So now in the case of Jim, we'll simply use his height and weights to calculate. That'll be 80 divided by 1.8 squared. Okay. On the other hand, for Jonathan, because he also got weight and height, but the values for weight and height for him will be different. So that's why you apply the same formula. Okay. You can see, let's compare this formula here and this formula here. They're basically this two different instantiations of the same formula, being weight divided by the square of height. But now in the case of Jim, we're going to apply weight being 80 and height being 1.8. But for the case of Jonathan, we're going to apply weight being 90 and height being 1.73. Okay? Okay, so now that's about the person. If that's about a person example, let's do another example very quickly about the two-dimensional points. Okay, so now points on a two-dimensional plane are identified by their assigned distances from the x and y axes, x coordinates and y coordinates. Now you can sort of get a feel. Since we talk about the points, this can be a kind of entities, and then for each point entity, they can be identified by their x and y coordinates. So we got two attributes, x and y. A point may move arbitrarily towards any direction on the plane. It may move up, down, left, and right. So these are the possible behavior. So given 2 points, we can also know the distance between them. For example, over here, you can see we got P1 and P2 over here. So we may want to know what's the distance between P1 and P2 over here, right? Between 2, 3 and 4, 1. Okay, so this is just another behavior. So now we can define a template which will characterize all the two-dimensional points. So what will be the common attributes and behavior? The common attribute can be the x and y. So these are identified by the nouns. You can x and y axis. And then they also got common behavior. How do they move up? If you want to define the way you move up, okay, let's do a very simple illustration first of all. Okay, so now, let's say we have two-dimensional entities. To really classify them, we have a template called point. Okay, over there we have attributes which will be x coordinates and y coordinates. So these are the common attributes. Everything common, I'll just say in this color over here, x and y. And then I'm going to use a different color for the instance specific values. Okay, and now what about for behavior? It can be, for example, move up, and it can be move left. How would you define to move up for a particular point on the two-dimensional plane? To move up, you can say increments the y coordinates, and move left will be decrements the x coordinates. Okay, let's see some example. Let's say we have two instances. Okay, so let's say we got P1 over here, and then we got P2 over here. Let's say P1 is 2 and 3. P2 is 1 and 4. Okay, so now you can see that we have two different instances. Okay, we got P1 over here and P2. Both of them have x and y. So x and y are the common attributes, but the values might be different, right? So let's use red over here. For P1, the x is 2. For P2, the x is not necessarily the same. It can be different. It can be the same. In this case, different, 1. And for P1, the y value is 3. And for P2, the y value is 4. You can see both of them have the same. Both of them have the same attributes, x and y. However, their instance-specific values might be different. It can be 2 versus 1, or it can be 3 versus 4. Okay? So now, what about when we talk about behavior? When we talk about behavior over here, again, let's say we have P1.x and P1.y, P2.x and P2.y. Okay, let's say we have that, and we already know what they are. It's 2, 3, 1, and 4. Okay, that's what we have. Let's say we begin with this. And then let's say we apply some behavior. When we say P1 dot move up, and then we do P2 dot move up. By the way, you can see over here, so these attributes, x, y, x, y, so these are common among all the points attributes, right? And on the other hand, the P1 over here and P2 over here, they are the context. So they really tells us which entity specifically we're going to look at. That means we may have entity-specific values. When we do P1 that move up and P2 that move up, so how is that going to change the story? I just put it back again. So let's say we got P1.x, P1.y, P2.x, and P2.y. Okay, that's what we have over here. Okay, we know that according to the definition for move up, we know that for every point, if you say a point is going to move up, we're going to increment its y value. So the way they move up is all the same. Okay, there's no difference about how they move up. But what's going to be the consequence? The consequence can be different. Okay, so now let's see specifically So now over here we say we have move up and move up. We are going to apply the same definition about moving up to P1 and P2. However, P1 and P2, they are different context objects or different context entities. When you say P1 that move up, basically you're going to have the following. So P1, we're going to increment y. P1 dot y used to be 3. So now when you say P1 that move up, P1 dot y should increment to 4. And then P1 dot P, what about P2? So P2 that move up, P2 dot y is going to increment from 4 to 5. Okay? And then what about the x value? They should stay the same because move up doesn't change the x. Okay? They stay the same. So 2 and then 1. So what does this really mean diagrammatically? So now you can see the new position for P1 is now going to change. Okay? So let me just, so P1 and then P2. And then we also talk about the x and y, x and y, x and y. Okay? So now what's going to be, what does this mean? When you say P1 dot move up, P1 used to be over here, P2 used to be here, let's say. So now P1's new position is 2 and 4. So that means slightly above. Okay? That's 2 and 4. Versus, so now P2 is 1 and 5. So 1 and 5 over here. So that makes sense because to go from here to here, here to here, that's after P1. That's after P1 dot move up. Okay? On the other hand, to go from here to here, so that means that's the consequence of P2 dot move up. So hopefully you have seen how things work. Even though we haven't done any programming, but I would like to explain to you in a way that will give you sufficient intuition about how things work. Okay, that's about attributes of behavior for two-dimensional points. Okay, so now we got attribute behavior. So now we got x and y coordinates for every point, and then the location might be different. Well, because different entities might be at different locations for the points. And then one is 3, 4, the other one is minus 4, minus 3. And then specific values, now they might exhibit distinct behavior. That means even though you're trying to apply the same behavior to, let's say you're trying to apply the same behavior like a move up, okay, over here. So we talk about move up over here. The same behavior over here, when you apply the same behavior but to different entities, either to P1 or P2, you might have different behaviors, okay? You might have different consequences. So now, for example, let's say you see a different example. You got 3 and 4 over here. If you move up, you get to 3 and 5. Just increment 4 to 5. On the other hand, if you got minus 4, minus 3, and apply the same behavior by moving up 1 units, you go from minus 3 plus 1 to minus 2. Okay? You can see this, the definition for the behavior is the same, incrementing the y value by 1, but the consequence of the new location for the points will be different. Okay, what about to calculate distances? Let's say if you got P1 over here, the distance from P1 to the origin, which has a location 0, 0, that will be applying the square root of the sum of the two squares, right? So that's this formula you should be familiar with. So now, to see the distance from P1 to the origin, we apply the formula with 3 and 5. And for calculated distance from P2 from the origin, we apply the same formula but with different x and y values, right? You can see the same definition of the behavior, but the values or the consequence you get might be different because the instance specific values will make it different, okay, in general. Okay, so now let's recap what we have said so far. We have seen two examples. One is the person, the other one is the points. But let's now try to recap very quickly. So a template, or in Java term, a class, defines what's really shared, what's really common by a relevant set of entities. For example, a template can be a person, can be a template, and points can be a template. They are different. So each template have common attributes. For example, you can see for the person template, you got age, weight, and height. For the point template, you got x and y. And then common behavior, which means a definition for the behavior. For example, in the person template or the person class, the way you get older is by incrementing the age by 1. And for the point class, the way you move up is by incrementing the value of y by 1. Okay. And each template may be instantiated into multiple instances. For example, for the person, we got 2 instances, Jim and Jonathan. They are the instances of person. The way you instantiate a particular template is by giving instance-specific values for the attributes. For example, for Jim, the way we instantiate Jim is by assigning the values for the weights, name, and height. And similarly for Jonathan. And also for points, we also got P1 and P2 as instances. And each instance may have specific values for the attributes, right? So now the values for the attributes are really instance specific. Okay. So now, for example, for the person template, for the person kind, so Jim's attribute value for age is 50, and Jonathan's attribute value for age is 65. Both of them have age, but the age values for both persons are different. Also, each point entity has x and y, but their x and y values might be different. For example, p1.x will be 3, and p2.x is different, -3. And p1.y will be 4, and p2.y will be -4, which is also different, right? So now, that's why when you are trying to apply the behavior is going to give you different consequences. For example, if you want to get, let's say if you say Jim get older, in that case, Jim is going to go from 50 years old and +1. So that'll be go from 50 to 51. Okay, the definition for getting older is by adding 1 to the age. And now, for a different context entity, Jonathan. So when you say Jonathan get older, you will go from 65 over here, adding 1. So that will become 66. Okay, similarly, also when you talk about the point templates, and because the way you define the moving up behavior is by adding 1 to the y value. Now, when you say p1.move up, you will go from 3, 3 over here. You can see location. Okay, let's say it used to be 3 and 3, and then if you move up, you're gonna add 1 to the 3. That'll be 3, 4. And then you can say P1 can P2. Actually, there's a typo here. That should be P2. You can also say P2 moving from -3, -4. Now the -4 is a different value for the y attributes. In that case, that we go from -4 plus 1. That'll be -3. Okay. You can see the definition for the behavior of moving up is the same, adding 1. But because the y value for each entity might be different, so the consequence can be different. Okay, so now finally I want to show you a very quick slides about, now given that we have gained some intuition about object orientation, we got attributes, we got behavior, we got methods, we got classes, entities, so these are the terms you want to review very carefully. So now, how do we translate all these into Java? Just a very quick review, preview, and then we'll talk about the details in later videos. So in Java, you use a class to define the templates, okay? And then you can also declare class over here, class, and then you can declare attributes, and also you can declare methods. Okay, for example, it's very easy. So you're gonna say public class, the name of the class, and then the name of the attribute age, nationality, weights, and heights. And now you can also say what kind of value is the attribute. For example, for age, it's gonna be an integer number, so you say int. For nationality, Canadian, British, Korean, it can be a string. And then for weight and height, they might have some fractional points. That's why you have double. Okay, it's for floating real numbers. Similarly, for the two-dimensional point, we just got another class called points. And then for x and y, usually you can have 2.4, comma 4.6, right, for the location. So that's why we have double. Okay, so now for each attribute, you must have the name and also the type. And then for the class, you also must have a name. Okay, so that's about this video, just to give you some intuition about why object orientation is so useful by using two examples, the two-dimensional points and the persons.